Good evening to all, Honorable Chairman, Co-Chairman, Honorable Chairman Sahab, Sri Datta Sugar Factory, Honorable Scientists from Dias and Friends. I am Shree Heganna, working as Chief Agriculture Officer in Sri Datta Shetkari Sahakari Sakar Karkhana Limited, Shirol since 2013. And we have factory have a separate wing of cane development and well-established soil testing laboratory to assist the cane development. And from we run various sugarcane projects or to improve the yield as well as the soil, to improve the soil performance or the soil quality. During 2011, we have started with Mission 100 per acre of sugarcane, Mission 100 metric tons of sugarcane per acre, and then 150 metric tons per acre sugarcane production. And with this project, we have started our cane development schemes, but up to certain limit, after certain time, we got some limitations for the yield. At every stage, we have precisely used the technology. It may be the cultural operations, it may be the fertilizer applications, it may be the pest control, disease control. But the increased height, we got some limitations to that. And when we look up to why it is so, when we look back, we focused on 2 points. That is the soil, one is the soil organic carbon, and secondly, the soil health or the soil salinity or waterlogged, prolonged waterlogging conditions of the soil in our area. And initially we decided to work on on soil organic carbon. And from 2011 up till today, it was initially, the soil organic carbon level was on an average, it was 0.3%. And now from last 3 or 4 years, it is stable up to 0.85%. Some farmers have more than 1% soil organic carbon also. And after that, to improve the problematic soils like soil salinity or waterlogged soil, prolonged waterlogging conditions, we have decided to go for the artificial subsurface drainage to improve such soils. It may be saline soil or it may be the waterlogged soils. And selected in our area, we have selected some villages where this problem of waterlogging and soil salinity was severe. And these are some locations where we have implemented such projects on community basis. Where we have implemented the project, where the soil is deep black cotton soil, highly fertile soil with high amount of clay percent and high cation exchange capacity. Along with these soils, we have implemented on both type of soils, that is chemically damaged soils or chemically infertile soils. That means the pH or EC of such soils are beyond the norms, especially the electric conductivity of the soil, which is up to 24-28% electric conductivity was there in such soils. And secondly, the waterlogged soils, that is the physically damaged soils, where the soils, the chemical properties of the soils are within the norms. But due to the prolonged waterlogging conditions, weeks together, months together, the waterlogging conditions, you can see in the video, that is the surface ponding is there. After heavy irrigation or after heavy rains, there is a surface ponding is there or waterlogged conditions prevails months together, due to which the fertile soil becomes non-productive. And under such soil conditions, we have decided to go for the subsurface artificial drainage project with perforated pipes. If we see the extent of the soil degradation at the national level, it is 6.72 million hectares, which is affected with the saline and sodicity. And in Maharashtra, it is 6 lakh hectares. And if you You look at the Shirol Tehsil, where the factory is located. Out of total cultivable area, that is 36,000 hectares, 10,000 hectare soil is affected with the soil salinity and the waterlogging conditions. From 2015, we started this project with soil reclamation project. Until today, the project is considered as the Datta pattern of soil reclamation project and consists the project 23 villages, and out of what area covered is 3,250 hectares of land with main pipelines of 210 kilometers, and SSD completed area is about 1,200 hectares. This area is now, the farmers are growing very well crops in this area. The features of this project, total project, is farmers have invested the total funds which is required for this project. Closed pipeline is the another most important feature of this project, and which is the key for the success of the project. I will explain you why it is the key for. Individual design is provided for 20 guntas also. Farmer, for every field, we have provided the individual design and controlled drain. Controlled drain to maintain the field capacity of the soil or to retain the soil moisture. These are the components. In first picture, we can see the DWC pipe which is used for the main drain, as a main drain. Initially, it was used. The open channels were used to drain out such water from field to the end point. And when we went with the farmers for the subsurface drainage, the farmers told us that open channel was the main constraint while we are going to implementing this project, because the efficiency of main drain to carry the water from field to end point was very low, and the lifetime of the open channel is very short. It remains for only 2 or 3 years. It comes in working. After that, the efficiency goes down. And to overcome this problem, our chairman sir decided to go for the closed pipeline, and we have tested that closed pipeline also for its strength to sustain the load of the soil, because we have put this main pipeline under 20 feet, more than 20 feet depth also. Then that is one RCC inspection chamber is provided for every 10 to 12 acres of land, just to inspect the total system which is running properly or not. And last year, the total system, total drawing and design, total spacing, depth, and drawing and design and implementation, we have got the copyright from the central government of the total area. These are some guidelines given by the Central Soil Salinity Research Institute, Haryana, which is the Apex Institute, which works on the reclamation of such problematic soils. And according to the soil type, light, medium, heavy, and very heavy soils, they have recommended the drainage spacing and drainage depth also. And in our area, we have decided to go for the 50 meter spacing and 1.2 meter depth, and which is working very well in our area. For the research purpose, we have selected 2 different locations, that is one from river Varna basin and one from the Koyna river Krishna basin, 2 different rivers which provide irrigation water to our in our area, and soil samples were collected from various depths, that 0 to 30 centimeter, 30 to 60, 60 to 90, and 90 to 120 centimeter, and analyzed for the various chemical properties as well as physical properties. And you can see the impact within 2 years. the soil pH before and after when we analyze the soil samples before the SSD implementation and after the SSD implementation, there is slight increase in soil pH is observed. It may be due to the easily leaching of the sodium carbonate or sodium sulfate, which are easily soluble in water rather than the sodium carbonates and bicarbonates, but there is the increase in pH is very marginal. But if the electric conductivity is compared after the before and after the SSD treatment, there is a drastic decrease in electric conductivity was observed in both cases and at every depth, and around about 60 maximum up to 96% decrease, but on an average we have got 60% decrease in the electric conductivity within 2 months of period. That's accordingly the elements which are responsible for the electric conductivity, that is calcium, that is in every element the calcium content also found decreased by to 73%, maximum up to 73%. In second villages it is 82%, 83% decrease in calcium content it was also observed. That's likewise the magnesium content in both cases before and after, it is 66% in Sedshar village and 84% decrease, maximum decrease is observed in magnesium content also. Likewise sodium content, minimum 50% and maximum 84% decrease in sodium content of the soil is observed within two years period. Well, physical property one we have analyzed for bulk density, and physical property, that is bulk density, also observed reduced by not much extent but up to 6%. The bulk density is also observed reduced within 2 year period. It may be due to the leaching of sodium element from the clay particle. It may be. Secondly, we have one challenge in our area, as I explained earlier, the waterlogging condition or the field maintenance of field capacity. And by using the subsurface perforated pipes and subsurface drainage project, it is possible even after heavy rain or even after flooding in Krishna River or Varna River, within 2 or 3 days, total standing water, surface standing water gets removed from the field when we start the that is the control system, drainage system. This was very important because before implementation of SSD, it requires weeks together to field to come to its field capacity. But after implementation of SSD, within 2-3 days, the field comes to the field capacity, which is more important for the aeration in the soil. That is the drastic change or drastic effect where we have implemented the SSD project. And ultimately, our main aim is the increase in the yield. And we have 4 or 5 farmers were studied before and after implementation. There is 50% more yield within 1 year after 1 year of the implementation of the SSD, and in some cases there is 100% yield improvement is there, because some area was the farmers were not cultivating some area from last 20 to 25 years. Single plant they cannot able to grow the single plant or single crop from last 20 to 25 years. In such area or such field, they are growing various crops, not only sugar crops. They are growing various vegetable crops, flower crops, and all that crops. Some regards to implement this project, the Institute of Central Soil Salinity Research Institute, VSI, MPKV, we have got their guidance, and under the guidance of all these, we have implemented the project. Some experts visits are there from VSI to Raichur with MPKV and all that. Conclusion, no doubt this subsurface drainage project or the subsurface drainage system is the proper and 100% assured technology which can improve the soil or which can improve the problematic soils. But such projects should be implemented on community basis. Individual farmer cannot do at all. Drain depth, drain spacing, and grade of the total system on which the total system runs, the grade, these 3 points are very, very important for the success of this drainage improvement. And finally, it definitely helps to improve the socio-economic status of the farmers within few days or within 1 year. This technology definitely helps to improve the socio-economic status of the farmer, and definitely this system is going for nation building system. And he is the person, Honorable Chairman J. Patil, our chairman, he is the person who is looking after the total project. And under the guidance, under the support of his institute, the Datta Sugar has completed the total project. Thank you very much.